Happy morning, friends. Today we are going to see the Truss analysis. So this is a problem given. Determine the support reactions and forces in all the members. So this is the diagram given in the question. So we have a simply supported truss. It's placed over a hinged support at point A and the roller support at point H. Then we have applied forces 20 kilonewton, 50 kilonewton and 20 kilonewton. So we know the hinged support is going to generate the two reaction forces. One is vertical, which is VA, and horizontal reaction force, which is HA. And the roller support is going to generate the vertical reaction alone, which is VH. So now we are going to find the support reactions first, which is VA, VH, and HA, by using the equilibrium condition. So this is a equilibrium condition, summation of horizontal component equal to 0. So we know there is no horizontal force applied over the system. So automatically the HA becomes 0 because there is no horizontal force. Then the second condition is the summation of vertical forces is equal to 0. So what are the vertical forces over here? Which is the vertical reaction force at point A, the reaction force at point H, and the applied load. The three loads which is applied over point C, E, and G. These are the vertical forces. So we know that the upward force VA and VH, it is in positive direction. Then the applied load 20 kilonewton, 50 and 20 kilonewton, which is in downward direction. We put positive for upward force and negative for downward force. So the summation of vertical forces, it will be VA minus 20 minus 50 minus 20 plus VH, which is equal to 0. So the equation comes like this: VA plus VH is equal to 90. Make it. So make this as a equation 1. The next thing we are going to apply the third condition: summation of moment at point A equal to 0. So fortunately at point A, these two reaction forces is not going to generate the moment. The remaining applied force 20 kilonewton, 50 kilonewton and 20 kilonewton. Then the reaction force at point H is going to generate the moment at point A. This moment generated by these three applied forces, it will be in clockwise direction. So we are going to put positive sign for that moment. Then the reaction force VH is going to generate the counterclockwise moment at point A. We are going to put minus sign for the moment generated by VH. Now come to the third condition. The moment at point A is equal to 0. The moment generated by 20 kilonewton is force into perpendicular distance. So 20 into 2.5 plus the second force 50 kilonewton. The distance between point A and 50 kilonewton is 5 meter. So 50 into 5 plus 20 into 7.5 minus, because this VH generate the moment in counterclockwise, so that's why you put negative sign over here. VH into the perpendicular distance is 10 meter equal to 0. So this is the third condition. By applying this condition, we are going to get the reaction force VH. So we got 450 by 10, which is 45 kilonewton. So this is the reaction force at point H. Now we can substitute this VH in equation 1. We are going to get VA plus 45 is equal to 90. From this, we can get the reaction force at point A. VA is equal to 45 kilonewton. Now we got the reaction forces at the support: VA, VH and HA. Next, we are going to find the forces in each member by using joint method. First, we are going to take the joint A. So in point A, we have two members AC and AB and one reaction force. We know that the horizontal reaction force is 0, so only vertical reaction force is considered at joint A. So these are the forces acting over joint A: FAC, FAB and reaction force BA. To solve this, we are going to apply the equilibrium condition. Before that, we have to find the inclination between this FAC and FAB. To find this inclination, we are going to consider this triangle AED. Okay, come to the triangle in AED. So we have the distance between AD, which is 5 meter, and DE is 2.5. How we get this ED as 2.5 means in triangle EBD we have an angle 45 degree. So if the angle is 45 degree means BD is equal to DE. So we got DE equal to 2.5 meter. So now come to this triangle AED. We have opposite side and adjacent side. So we can get the theta value tan theta equal to ED by AD, which is 2.5 by 5. By using this we can find the theta value, theta equal to tan inverse of AD by AD, which is 2.5 by 5. The theta value is 26.56. So now we got the theta value over here. So you can apply the equilibrium condition. The first condition is summation of horizontal force is equal to 0. So horizontal force is FAB. Then we have to find the rectangular component of this FAC, which is horizontal and vertical component. So horizontal component is FAC cos theta. So if you are considering the horizontal forces, FAB plus FAC cos 26.56 is equal to 0. Make it as the equation 2. Then apply the second condition. The vertical forces is equal to 0. So vertical force is VA and the vertical component of a FAC. So VA plus FAC sine 26.56 is equal to 0. So we know the VA value, which is 45 kilonewton, plus the sine 26.56 is 0.447, FAC equal to 0. By applying this, we can find the FAC value, which is minus 100.67 kilonewton. This negative sign indicates that it's a compressive force. So normally we assume the force on each member as a tensile force. The force facing outwards from the joint. It is a tensile. We are assuming that it's a tensile force, but we got negative sign. This negative sign indicates that the applied force is a compressive force. Okay. Then we are going to substitute this FAC over equation 2. If we substitute this FAC, we can find FAB. So FAB value is 89.446 kilonewton. So it's positive. So the assumption is correct. It's a tensile force. Next, we are going to consider the point C. So in point C, how many members are acting over the point C? Point C is, we have 1 CE, CB and CA. We have 3 members and 1 applied load. So we find this inclination 26.56. So we are going to use that inclination over here. So it's a 26.56. You have to draw a horizontal line from the joint C. So you have to find the inclination between the member force with the horizontal reference line, which is 26.56 on both sides. Then we have 2 vertical forces. Now we are going to apply the same equilibrium condition. So first condition is summation of horizontal component equal to 0. So what are the horizontal components over here? We have horizontal component for FCE, which is facing in a rightward direction. Then FCA, it facing in a leftward. So you have to put minus for FAC. FAC cos 26.56. Then FCE cos 26.56 is equal to 0. Make it as a equation 3. Then apply the second condition. Summation of vertical forces is equal to 0. So vertical forces means 20 kilonewton, FCB, the component of these two forces, FCE and FCA. So FCA is in downward direction. So we have to put minus for FCA. FCE is in upward direction. So we have to put positive sign for FCE. So make it as a equation 4. Now in equation 3, we know the value of FAC. So FCA is equal to FAC. So you can substitute that value over here. By substituting that value, you can find FCE value, which is minus 100 kilonewton. Again, we got the value in negative, but our assumption is it is a tensile force. The force is facing outwards from the junction. So, but we got the negative answer. So the negative sign indicates the assumed force is wrong. It's a compressive force. So it's facing towards the junction. Okay. Then substitute this FCE in equation 4. By substituting that value in equation 4, you can find FCB. So FCB is minus 20 kilonewton. Again, it is in negative direction, so it's a compressive force. After completing this, we find FCE, FCA, FCB. Now we can switch over to the joint B. So joint B. So joint B. In B we have BD, BE, BC, BA. 1, 2, 3, 4. 4 members are there. So we are going to consider the 4 member forces, which is FBD, FBE, FBC, FBA. We know the inclination FBE with the horizontal line, which is 45 degree, is given in the question. So this is the only force is inclined with the horizontal line. So we have to resolve this into vertical and horizontal component. So by applying a equilibrium condition, summation of horizontal forces is equal to 0. So horizontal forces is FBD minus FBA, then horizontal component of FBE equal to 0. Make it as a equation 5. Then supply the vertical forces is equal to 0. So vertical forces is FBC and vertical component of FBE. So we know the FBC value, which is minus 20. By substituting this minus 20 over here, you can find the FBE value, which is 28.28 kilonewton. So after getting FBE, we can substitute this FBE in equation 5. So already we have FBA. Okay. So we have to substitute this FBA value over here. Okay. In equation 5, which is minus 89.446 plus FBD plus we have FBE value, which is 28.28. So cos 45 equal to 0. So by solving this, we can find the FBD value, which is 69.45 kilonewton. Okay, we find the unknown value in joint B. So now we can move to the joint D. So now come to the joint D. So in joint D, we have 3 members, DF, DE and DB. So we have to consider this 4 member forces, which is FDF, FDE and FDB. So by applying the equilibrium condition, so we have to apply the equilibrium condition, summation of horizontal forces equal to 0. So horizontal forces is minus FDB and plus FDF is equal to 0. So we have this value FBD, which is equal to FDB. So you can substitute this value over here. You can get FDF is equal to FDB, which is equal to 69.45 kilonewton. Then apply the second condition, summation of vertical forces is equal to 0. So there is no another forces over here. So FD is equal to 0. So we got all the number forces over here. So now we can give the value for the number forces. So point A, we have a reaction force 49 kilonewton. In AC, on the AC we have a compressive force, which is 100.67 kilonewton, which is acting towards the junction. Then we have applied force 20 kilonewton. Then in AB we have a tensile force 84.9446 kilonewton. Then in between C and B we have a compressive force 20 kilonewton. Then in CE we have a compressive force 100 kilonewton. In VE we have a tensile force 28.28 kilonewton. Then in BD we have a tensile force 69.45 kilonewton. In between D and E force is 0. Then we have applied force 50 kilonewton at point E. So this is the left side of the total system. So we find the forces in left side. But the total system is symmetric about DE. So it's a symmetric about DE. So we can apply the same force system over right side. So that's what I mentioned over here. The truss is symmetric about the line AD. So same forces is considered for right side members. So this is the answer for the given system. We find the reaction forces and the member forces over here. Thank you.